I'm a senior R&D engineer and employee number 5 at a startup, building IoT devices for our customers who are large utility companies rolling out smart city projects. I have a lot of different jobs. One of them is making sure that our devices are reliable and will last more than 7 years before needing a new battery. About half of our prototypes had problems. They were using much more power than we expected. We couldn't figure out why. All of our lab testing showed that the power consumption was lower. These things aren't in easy to reach places. Would you want to replace batteries early on 10,000 flow sensors? My boss and our investors were worried.
This isn't an unusual situation. Power consumption testing is a tricky business, and IoT devices have the unique challenge of needing wireless connectivity and long battery lifespans. We worked with this customer and found 2 separate problems. The low power operating condition required a tighter tolerance on the power supply rails. Fast transients on the power rail were being generated by data transmission, and that was interfering with the device clock. By using our patented high dynamic range and fast sampling power sensing technology, we were able to identify the problem. The customer changed some power supply components and eliminated the coupling. There was a second problem. The devices behaved as expected in most environments, but not when operating at the edge of the cellular network. Intermittent connectivity was causing the device to retransmit data too often, draining the battery at more than 50 times the normal rate. Our UXM wireless test set can emulate many different types of cellular networks, including Cat-M1 and NB-IoT specifications. With this capability, we were able to help simulate different network conditions, including intermittent connectivity, and determine that the device was too aggressive at attempting to reconnect to the network.
I was impressed with the engineers from Keysight. With their help and with their test equipment, I found the problems, changed some components, rebuilt the firmware, and got the product out on time. That wouldn't have been possible without them.